All right, let's apply some of the concepts we learned in Chapter 4, Part 7, where we learned about translating categorical propositions in ordinary language into standard form. So today, let's look at some examples of entire arguments in ordinary language and how to translate them into standard form categorical syllogisms. So let's start by figuring out what are the terms and the propositions involved in this argument here. It says physicists are the only scientists who theorize about the nature of time. This means that all scientists who theorize about the nature of time are physicists. If we read that sentence, this is logically equivalent to it and yet is in standard form, and so it's more precise and easier to perform logical operations on. So we have two terms, scientists who theorize about the nature of time and physicists. In this next part, we have Stephen Hawking does that, i.e., Stephen Hawking theorizes about the nature of time. And remember that we need to have it in standard form, so we say all people identical to Stephen Hawking rather than just saying Stephen Hawking. And this is a concept from 4.7 you can look back on. And all people identical to Stephen Hawking are scientists who theorize about the nature of time. So this is just consistent with the term used in premise 1 and to show the structure of this argument. So therefore, the conclusion here says Stephen Hawking must be a physicist, and our term translation for Stephen Hawking is people identical to Stephen Hawking. So we're going to be saying that all people identical to Stephen Hawking are physicists. So that's the translation of the argument into standard form. It contains three terms: scientists who theorize about the nature of time, physicists, and people identical to Stephen Hawking. And we can see that people identical to Stephen Hawking is going to be our minor term, and physicist is going to be our major term. Let's assign each term a letter just so we can simplify this argument out. All S are P, all H are S, therefore all H are P. That's going to be a symbolic version of this argument. And this is going to make it easier to check it for validity using the Venn diagram method. So H is our minor term, P is our major term, which makes S our middle term. And that means this argument is in standard form because the minor term comes second in the premises, as it should. And just for some practice, let's also figure out the mood and figure of this argument. So it's diagonal, the middle is diagonal top to bottom, that's figure 1. The propositions are AAA, so we have an AAA1 proposition. Now let's look at which are distributed. Universal distributes subject, negative distributes predicate. So that means the subject is distributed in all three of our propositions. That means, according to the rules, the middle term is distributed, H is distributed in the conclusion and also distributed in at least one premise. So we're good there. There are affirmative propositions here. We're not doing the negative problem. So it looks like it's not breaking any rules. Let's double check that using Venn diagram. So minor term on the left, major term on the right, middle term on top. Fill in the premises only. So all S are P would mean we are going to shade every S that's not a P. All H are S means we're going to shade every H that's not an S. That only leaves that little tiny region of the H circle, and it's also intersecting with the P circle, so the conclusion does follow, and this is a valid argument. So there you have it. If we're going to translate an ordinary language argument into standard form, we just need to figure out the terms involved. And we use this as practice to apply some of the other concepts we've learned in this chapter as well.